Hey there. My name is Braxton Woodham, president of Unfinished Labs, and
my name is Harry Evans. I'm the CTO of Unfinished Labs.
So we're kind of partners in crime here today. We'll try to figure out how to talk this through in the least awkward way possible. But we're here for a really big moment in the kind of course of our program we've been on now for a while. This is the culmination of years of work and really over a decade of thinking. So we're excited to be here today and appreciate all of you being here with us to talk about this next kind of phase of the journey we're on. So I'm going to find a clicker here and take you through it. First, I want to talk about some background why we got into this project. We believe that if you look at what's happening today, one of the horrible miscalculations of the recent era of the web and what's known as Web 2 has been to put our entire social network into a handful of proprietary platforms, and that led to the surveillance economy we live under today and all the ensuing problems that have come out of that. And we don't believe it's viable to rely on one person like Zuckerberg or an Elon Musk or any individual to solve this problem. And so, thank you. We think that, for a long time now, we've been talking about the opportunity to change this is really with protocols, not platforms. That's something that I've been in those discussions for over a decade now. And recently, it was in 2019, Mike Masnick's paper really said that eloquently. And if you haven't read that, I would urge you to give it a read. The challenge with protocols versus platforms in this particular domain come with the fact that we need shared state for social networks. So if you think about HTTPS or TCP/IP, those protocols really are for data in motion. But once you need shared state, in our case, you need that for the social graph, you need a way to store that information without it being in a proprietary database. And that's where blockchain comes in, right? The potential to actually have this information stored in a truly decentralized way using trustless protocols. Once you do that, you open up the possibility now for individuals to control their identities and their information, and that then opens up completely new landscapes, we believe, for use cases and business models, and really just an opportunity to completely rewrite the script here on what's happening in our digital spaces. So when you walk through the process here, for us, what we came to realize was phase one is to develop a public protocol, and we call that DSNP, the Decentralized Social Networking Protocol. And that protocol has two key elements that we think are extremely important and really critical for success. Number one, that protocol is not tied to any blockchain or token or any economic incentive whatsoever. And we think that's critical because once you have an economic incentive model, you're at risk of capture somewhere down the line. And for engineers like us, it's hard to predict how that can happen, where the compromise will happen, but it inevitably will happen. And so the first piece of the puzzle is to have the protocol not be tied to economic incentives. The second piece is then to focus on the right domain aspects. And in our case, that's tying together self-sovereign identity. We're not that solution, but tying that together with personal data and to create public spaces where we can now have the authenticity to really build trust back again. And that's kind of one of the interesting things about this is leveraging trustless technology to help society at large build back trust at scale. So once you look at doing that, you then need to, just like for the web, you have a web server that makes HTTP, makes the web a reality by implementing HTTP. You need the same kind of thing here. You need an actual blockchain to implement DSNP. The challenge there is blockchains historically have been optimized for financial transactions, not social media messaging, which has a very different dynamic. And so, if you think about blockchains, the high cost and high volatility of the transaction costs really is not workable for social networks. We prototyped this on Ethereum and saw a 40x swing in transaction costs during the time that we built our entire stack testing out our DSNP protocol. So what we did was we had a team work for months to look at kind of the full landscape. We looked at over 30 different blockchains, and we looked at aspects like state sharding, different consensus mechanisms, and what we finally concluded was that Polkadot had the best and most elegant solution for resource allocation via the layer 0 chain, the resource relay chain, that could then allocate resources out to a layer 1 chain that we could build to be optimized for the specific dynamics of social networking. And that's what we're here to really announce today. So this really is the culmination of, like I said, over a decade of thinking, years of work by a lot of people, and Harry's been kind of leading the charge, and he's going to talk a bit about this particular piece of technology that we're unveiling today. But I want to first talk about what we're calling it, and we're really excited to announce for the first time anywhere that this is going to be called Frequency. So we hope you see a lot more and hear a lot more about Frequency in the coming days and weeks. And we're really excited about this name, actually, because of two key kind of aspects, at least for me, that meant a lot when we started talking about this. Was number one, back to the original kind of reason we even got into this project. We thought it was really important to rebuild our digital public infrastructure so that we can kind of all get on the same frequency as a broader society and start communicating in a really authentic and positive and productive way again. And number two, when you look at our actual solution, which Harry's going to talk about, it's really apt because of the way we approach the kind of frequency of resource allocation around these messaging bandwidth allocations and so forth. So he'll talk a bit about that. But the bottom line is we're thrilled to be announcing this today. Appreciate y'all being here online and in person to learn about this. And I'll come back in a minute. We'll talk about next steps. But I want to hand it over to Harry and give you the floor to take folks through the details.
Thanks. Speaker notes, just in case. Thanks, Braxton. So I'm very excited about the announcement of Frequency as well. And to explain sort of what that name means to me, I wanted to ask you a question. If you could change how blockchains work, what would you change? What would you change? I would change pricing, specifically transaction pricing. I would create consistent, reliable, low-cost, low-volatility transaction pricing. Why? What does this even mean? Let me illustrate with an example. When we look at Ethereum, why are Ethereum gas prices so high? And why are the prices for Ethereum gas so volatile? Even after things like EIP 1559. Why do we see, as other blockchains gain traction, them moving in the same direction, the same cost problems, the same congestion problems? I think I can help explain this a little bit with a story. In the mid-1970s, an economist named Alfred Kahn got the opportunity to apply an economic concept called marginal cost pricing to the retail electricity market right here in the state of New York. And then later, as part of the Carter administration, he applied the same concept in the deregulation of the airlines to the sale of airline seats. Now, Kahn theorized that marginal cost pricing would create an economically efficient, price-based market system for the allocation and rationing of constrained resources. I'll come back to the rationing aspect in a second, but what does that mean? That's a lot of words. What is marginal cost? It's the cost of producing one more unit or one more increment of a good, one more kilowatt of power, one more unit out the factory door. And for many markets, this works really well. In electronics and computers, for example, the cost of a marginal unit, that one more unit of production, is significantly below the average cost of a unit of production. This is economies of scale. But for a constrained resource, marginal cost pricing has the opposite effect. It drives prices up. It drives volatility up. Trying to get one more kilowatt of power to keep the AC running during a heat wave and avoiding a rolling blackout. Buying one more airline seat, the last one, on a cross-country flight on a holiday weekend. And when those resources are fully allocated to the market, when there's no spare capacity at all, you see prices skyrocket and volatility become completely unpredictable. You see consumers compete with each other for those resources, trying to buy it out from one another. You see this in the electricity market. You see this when you're trying to buy plane tickets for the 4th of July weekend. And you see it in the Ethereum gas market. Why does this happen like this? Let me ask you a question. Why are we here today? Maybe that's too broad. Why Polkadot? For us at Unfinished Labs, it provides the specific tools for us to solve our use cases. It allows us to move from a high-cost, high-volatility world to a continually replenishing resource. Now, it creates Polkadot and Substrate create a context, a framework, a blockchain factory, if you will, that allows us to forge our purpose-built specific tools for the use cases we want to solve. Now, could we use a general purpose tool for this? Of course we could. People are solving use cases similar to this on Ethereum today. As Braxton mentioned, we prototype DSMP on Ethereum. But the real questions are, can you do it efficiently and in a sustainable cost model? I think the answer to that question, I would ask the folks that are competing to mint an NFT against transactions that transfer millions of dollars of value, let's say of ETH, between individuals. Or transactions that flash loan tens of millions of dollars in complex DeFi compositions. We don't, only the use cases that are the most valuable can survive that dynamic. All the other activities, all the other use cases, all the innovation is squeezed out by this marginal cost pricing. Now, we don't buy stocks and houses and cars and fine art and boxes of Cheerios in the same market or even the same marketplace. Markets have particular structures, particular dynamics. They have particular economics, and they have particular incentives. Braxton mentioned earlier that we looked at over 30 blockchains as part of our chain evaluation process. And this is what we recognized when we looked at all those blockchains, that Polkadot and Substrate gave us the tools that we needed to solve our specific use cases, which in our case is social networking. It allows us to focus on low volatility transaction pricing and domain-specific scaling models. By being able to integrate with the relay chain and its community of validators, it allows us to create specific incentive models for our community of token holders, because those incentive models don't have to be the same as ones that support finance or gaming or art. It allows us to take specific chain use cases and convert them from operational costs, i.e. transaction fees, into capital costs, i.e. investments into the ecosystem that we're trying to create. And in this larger community of parachains, each of these specific solutions to specific problems, we can cooperate versus competing to create even greater solutions. We at Unfinished Labs don't have to implement NFTs or ERC20 style tokens or even SSIDs. We can leverage the implementations that are already out there, and we don't have to outbid them for block space. This is how we're building frequency, and this is why we're building frequency on Polkadot. Frequency is the first production implementation, the first production manifestation of the decentralized social networking protocol. We think DSMP, that this work is one of the most impactful and important public infrastructure projects of our time, because it embeds social functionality in the web itself. And we don't have to wait for years for the tools to be built or the chains to be ready to run them on. We can build those today with Polkadot. Thank you.
Braxton. So we'll be,
You can do it next.
oh, there's another slide?
Yeah,
We'll be doing our crowdfunding for our slot really soon, so just if you could follow us, next slide, I think it tells you where. Here's all of our socials today's socials. Follow us there. You'll hear more from us soon. We'd love to have you kind of join in on this movement, because we think we're just a few people part of catalyzing a much broader movement here to change the web. Thank you, guys.
Look forward to seeing you.
I think we have a couple of questions if you guys have a few minutes.
Sure.
So we also have a mic going around if anyone in the audience has a question, but we have a few from the app. The first one being, maybe you could explain a little bit sort of the overlap and relationship between frequency and the broader Project Liberty.
Sure, I can take that one. So when we set out to do this project, you know, from my perspective, and I would believe Harry's, we had thought a lot about it as technologists, about this protocol versus platforms. Once we started working with Frank McCourt, we found an ally who was also a very strong conceptual thinker who could see this like we could, and we quickly realized that this is more than just about the technology. It's also about a separation of powers. We need to, decentralization is not just about the operational aspects of blockchain. We also think it's important to separate governance out from the domain of technologists like myself and like Harry, and start to look at intersectional skills with philosophers and political scientists. So Project Liberty was then expanded to support a technology track, which we are driving with a lot of really talented people. Some are out here, by the way. I see Indy right there and others. But we're driving that track. But there's a governance track that's kind of anchored around the McCourt Institute that was launched with Sciences Po and Georgetown to look at governance of these systems with intersectional skills brought to bear. And then we also realized that technology is just a tool. You can use a hammer to build a house or to kill somebody. So there's also a movement component here that's focused more on the cultural aspects of how this technology plays out. We don't want to leave that to chance. And so Project Liberty is an umbrella over a technology track, a movement track, and a governance track, all working in concert.
One of the questions on this list you sort of answered a moment ago. You mentioned the crowd loan would be soonish. People asking when launch. You're going to get it a million more times, I'm sure. So absolutely. Soon, trademark. Yeah. I think one that might be more in the tech direction. Can you explain more about how data storage will work in the system?
Sure. I mean, one of the things that we like the most about the parachain model is that you can customize not only the data like you can in a smart contract, but actually the incentive models and the chain functionality itself to the specific needs. So for our cases, we've taken a hybrid approach to the data sets. Some data is on-chain. Some of the most important data is on-chain. A representation of social identity, which is something less than an SSID, but gives us the nodes to connect a graph with. The graph itself as an on-chain structure with both private and public elements to it that allows for a level of composability. And then the messaging components of social networking where that's primarily off-chain with trust anchored back to the chain itself via batching and other technologies.
Thank you both very much. We're going to take a 15 or 20 minute break and we'll be back for the final segment.